Hello and welcome back to another Siemens PLC and FactoryIO tutorial. In this video we're going to be amending a little bit of the ladder logic code we wrote in previous videos, part 1 to part 6, which controls the conveyors. Once we've done that, we will then be programming the stacker crane to place pallets in the rack using the Siemens SCL. So if that is something of interest to you, then please stay tuned. Welcome back. Now let's get straight into it. This is the warehouse setup we created in the previous video, part 7. So I'm just going to change the name of the setup and save it as part 8 video. It just makes it a little easier to find as we create more videos as we go along. Okay, done. And we'll start up the TIA portal and open up the program prior to us adding the stacker crane. We will also save this one as part 8 video for the same reasons as we did the FactoryIO setup. The first thing we will do is create a new tag table, and then I'll rename it tag table 2. Then let's open the tag table and start entering the additional tags required for the warehouse I/O we added in part 7, the previous video. Just to let you know an interesting trick, as I've programmed this setup before, I decided to export the tags from the program so that I could import them into this program and save time by not having to retype them all in. The way we do that is by selecting Export in the tag table to save the tags, and then when we want to import them into a new program, we select the import function, which we're going to do in just a moment. Right, let's cancel that for now, and I'll just enter the first few tags to explain the name convention I'll be using. Let's have a look at the way we set up the wiring with the tags in FactoryIO. All the inputs go from input 1.6 to input 2.3. And we'll name the inputs in the tag list I_S_crane followed by what they are. So the first one would be MOVX, and the address is automatically assigned as the next available input, input 1.6. Now let's have a look at the outputs from Q1.3 to Q1.6 and QD104. We'll use a similar convention, but this time we'll use O_S_crane followed again by what they are. However, as mentioned earlier, I'm not going to type them all in. Instead, I'll import the exported list. Let's select Import and then find the file. I've exported it as PLC8 video tags.xlsx. So I'll select it, then open, then select OK. Then select OK again and see the information entered in the tag table 2. It looks like I used S-crane instead of SCRA, in which case it has duplicated the input, so I need to delete the first one. I should be able to right-click, then select Delete. OK, that disappears. Let's rearrange them a little better. I'll move input 2.3 under input 2.2 by inserting a row, then copy and pasting the eye reflective sensor 5 in place. Then I need to delete the one I copied and rename the copied input. Let's do the same for the outputs by cutting and pasting output Q1.6 under Q1.5. It just looks a little better to keep it all like this, but it really isn't necessary. But I just decided to do it. So if you want to leave them as they are, that would be fine too. That's done. We also have some internal bits, M1.0 to M1.3, the use of which will become a little clearer as we start to code. Okay, let's save the project and go to the first network in the program. So before we get into SCL programming, we need to make a few changes to the ladder logic. Now, as we programmed the conveyor system in ladder logic, I thought it would make sense to make modifications to this part of the system in ladder logic, then program the stacker in SCL. It also makes it easier for debugging. There's actually not much ladder logic code to amend, but the first thing we should do is tidy up the code in the first network, as the resets are getting a little complicated and taking up a lot of room on the screen. So let's make a start. We need to delete all 8 resets and replace them with a single function reset. So let's right-click on all the reset coils and delete them. Here we go. Let's leave 2 of the branch arrows in place so we can add other ladder logic functions to them. And under bit logic operations, we need to bring down a reset bit field. Then we can enter M0.0 in the first field and 8 in the second field, which means all internal bits from M0.0 to M0.7 will be reset on startup of FactoryI. Now we'll bring down another reset bit field, and this time we'll add in the address M1.0 in the first field and 4 in the second field, which will reset M1.0 to M1.3 on startup of FactoryI as well. These are the additional tags we just entered in tag table 2. Now we can start entering some ladder logic code. Let's have a look at the warehouse, and what we need to do is start up loading conveyor 1 as soon as a pallet passes the left entry conveyor. Now we already have some of the code in place, so we just need to add another internal set output coil under the transfer left reset coil. Therefore, as soon as a pallet passes the sensor, a rising edge will occur, and we will set the loading conveyor 1 M1.1. Okay, let's enter that in. We need a set coil, then enter M1.1. Okay, done. Now we need to go to the outputs network at the bottom and enter the logic so we can start the motor on the loading conveyor 1. So let's enter a branch and a normally open contact with the address M1.1. Then an output coil, and we will look up the address in the list. O_loading conveyor 1. Not sure why I put Q there. I suppose it's for outputs. Okay, that will start loading conveyor 1, although I don't want the loading conveyor to continue when a pallet reaches the reflective sensor 5. So let's add a normally closed contact here in series to stop Q1.6 as soon as input 2.3 the reflective sensor is activated. And this is the internal bit M1.0 loading conveyor 1 loaded. Now we need to add the code in to activate this internal coil. So let's go to network 3 above and select insert network, and this will become the new network 4 where we'll activate the internal bit M1.0 loading conveyor 1 loaded. We'll call the network stacker loading ready. Now let's enter a falling edge trigger from the bit logic operations, and we'll name it F_trig_loading conveyor loaded, and enter. Then on the CLK input, we need to add the reflective sensor 5. We'll get that from the list. And we need a normally open contact on the output with the F_trigs queue. Now we can add an output coil for M1.0, which will stop Q1.6, the loading conveyor 1, in the outputs network. We can also add another coil in to stop the loading conveyor 1 motor. Okay, M1.0 should be a set coil and M1.1 should be a reset coil. Okay, let's download the updated ladder logic code to the PLC and run the system to see what happens. Okay, compiling. We need to continue without synchronization, which means there must have been another program in the PLC, and now we're replacing it. Let's select stop all. Now let's start the PLC and let's connect FactoryIO. Now we can orientate the system a little better to see what's going on. Let's go into monitoring mode on the PLC first. And we can put FactoryIO into run mode. Actually, I'm going to stop FactoryIO again and get the system to only emit palletizing boxes. So right-click on the emitter and deselect everything bar the palletizing box and go into run mode on FactoryIO again. Switch to auto, clear the box readout to 0 and press the green start button. Just to let you know, the panel functions were programmed in video part 3 to 6 if you'd like a refresher on that. Okay, let's see what happens. A tense moment. The first pallet stops at reflective sensor 5, but other boxes keep coming along and pushing the first pallet onto the stacker, instead of stopping and waiting at left exit. Therefore, if a pallet has reached reflector sensor 5, we need to set a latch to indicate the stacker is busy, and any further pallets coming down the left conveyor should stop as soon as they reach the left exit sensor. Okay, let's stop the PLC and make some changes to the ladder logic code. So in network 4, let's add another output coil and address it M1.2, which is the stacker busy, and use it in a new branch which will tell the left conveyor to wait with M1.3. Let's add the branch then bring down a falling edge trigger and name it F_trig conveyor weight and select OK. The input to this will be input 0.5, which is at left exit. And we need the F_trig Q on the output as usual. Then we can add a normally open contact for the stacker busy signal M1.2 in series with a set output coil M1.3 left conveyor weight, which will be used to halt the left conveyor. As M1.2 stacker busy is in series, we will only halt the left conveyor if a box is ready to be transferred or being transferred to the rack. Now let's go to the outputs network and add M1.3 left conveyor weight in series with Q0.3, the transfer left output for the yellow bed and chains, and in series with Q0.5 conveyor left to halt the long conveyor. Okay, that's all done. Let's download the updated code to the PLC and start the PLC. Orientate the FactoryIO scene and then start FactoryIO. We can then go into Auto and press the Start button and see what happens. Okay, let's have a look. The first pallet stops at the reflective sensor 5, which then should stop the next pallet at the left exit sensor and also stops the left conveyor too. Great, so now we can start programming picking up the pallets with the stacker crane and placing them into the rack using SCL code. So let's stop FactoryIO and stop the PLC and prepare for entering SCL code. To do that, we need to add a new block. We'll keep the name as block 1. Select a language, which could be any one of 3, ladder, FBD or SCL. We are obviously going to select SCL. Make sure function FC is selected, then select OK. Under program block, we now have block 1, FC1. And to the right, we have an empty block ready to accept SCL. We now can add the block to the bottom of the main OB1 ladder logic by dragging it into network 10. I'll name the network stacker code in SCL. Then drag the block down. Then whatever we enter into the block as SCL will always be added to the bottom of the ladder logic. Just as an example, we can now select an if statement and enter the conditions for the if. I'll just delete that for now and save the project so we can start entering SCL in the next video. So that's all for this video. In the next video, we'll actually start entering SCL code to pick up the pallets and move them into the rack, testing as we go along. So I hope you've enjoyed this video. Please remember to subscribe and hit the bell so that you'll be informed of future video uploads as soon as they become available. And also feel free to make any comments. Until next time, thanks for watching and hope you have a good day. Bye for now.